Hello, everyone, and welcome back to another planetarium show. My name is Jessica. I am the director of the planetarium, and with me tonight is one of the students who works in the planetarium. I will let him introduce himself.
Hi, I'm Eli. I'm a physics and astronomy student at UMD.
So, tonight we are going to take you on a tour of the universe. Now, there is a lot to see, so we're not going to be able to see everything, but we're going to do as much as we can in about 30 minutes. Now, as we are going on our adventure through the universe, if you have any questions, feel free to leave them down in the comments. Eli will be keeping an eye on that for me and will let me know as those questions come up. We'll also have time at the end to answer any questions that we don't get to right away. And just remember that there is a little bit of a delay between, when we're talking and when you see it on Facebook. So if it takes us a little bit of time to get to your question, that's probably why. All right, so I'm going to get switched over to, where's it at? There it is, to our program here. So the program that we are using tonight to take our tour of the universe is a universe software called OpenSpace. It's really cool. It takes data sets that astronomers have of like positions of stars and planets and galaxies, and it maps it in 3D space so that you can travel through it. And it is actually a free program if you are interested in trying it out for yourself. I have the link down in the video description. It is quite a beefy program, so it takes a lot of graphics and computer power to be able to run that. But if you want to try it out, you definitely should. And I am slightly rambling since I'm trying to get a poll activated here. There we go. Oh, yay, it's showing up. Okay, cool. So since we are trying to see the entire universe, we don't have time to stop at every single planet because, our solar system is a part of the universe. And so we do want to spend just a little bit of time looking at it, but we can't go to every single one. So I have put a poll up to hear from you guys. Which of the inner planets, Mercury, Venus, Earth, or Mars, would you like to go and visit? And while I give that a few minutes to get some responses, let's head on over to the object at the center of our solar system, which is, of course, our sun, the closest star to us. So since it is a star, just like the stars we have up at night, it is a big ball of hot gas. All of that heat and energy and light that we see coming from it comes from nuclear fusion in its core, where hydrogen atoms are being slammed together and they end up creating helium. And in that process, that gives off a lot of heat and light and energy. And that's what we see coming from our sun and other stars as well. The sun, of course, is the biggest and brightest to us just because we're a lot closer to it than we are the other stars. All right, let me go check this poll. So I'm seeing a split between Mercury and Earth. So you know what? Let's do that. Let's go see both of those. All right, so we will, let me pull this back up, go take a look at Mercury. Mercury is the closest planet to the sun. As we fly on in. And it looks an awful lot like our moon. And there's a pretty good reason for that. Our moon and Mercury are very similar. They're big balls of rock. They don't have an atmosphere, they don't have any volcanoes or plate tectonics or erosion, and so all we really see on the surface of Mercury is a whole bunch of craters from where bits of pieces of rock and ice, not really ice this close to the sun, but pieces of rock that are flying around in space sometimes hit Mercury and they leave behind these marks, these craters. And since there's no process to erase them, like a volcanic eruption or erosion, they just stay there. And so we have the surface just covered in them because Mercury has been hit a lot over the 4.5 billion years that the solar system has been around, that the planets have been around. Mercury, of course, does get extremely hot since it is the closest planet to the sun, daytime temperatures exceeding, I believe, 700 degrees Fahrenheit, so hotter than your typical oven. Although it's actually not the hottest planet, that honor goes to Venus. But nighttime temperatures drop down to -200 because there is no atmosphere to hold on to that daytime heat into the nighttime. And so temperatures plummet once there's no longer the heat from the sun warming the surface. All right, so the other planet that won our poll is Mars. And I'm actually going to get the other poll up real quick while we head on over to Mars. So Mars is the fourth planet, or no, it wasn't Mars, it was Earth, wasn't it? Eli, do you remember what I said?
Yeah, I can't see the survey either. Like I'm on it through the Facebook's account, but I can't see the results.
Yeah, it's on mine. I'm pretty sure Earth was the other one that won, and not Mars.
Yeah, it was
Okay.
Mercury and Earth.
Okay. Well, then we will head over to Earth, the third planet from the sun, our home planet. Looks quite a bit different than the other planets because it's the only planet that has an abundance of liquid water on its surface. We know that the Earth is about 75%, the surface is about 75% of it is covered in water. It, of course, is also unique because it's the only world we know of right now that has life on it. Even though we are searching, it's the only one we know so far. So that makes us pretty special. Earth also has a companion, our moon. Mercury didn't have a moon, and actually Venus doesn't either. Uh, Earth and Mars are the only two of the four inner planets to have a moon. And our moon does look a lot like Mercury for the same reasons. It's been hit a lot, those leave behind craters, and with no erosion or tectonics or anything like that, those craters just accumulate. They pile up over time and give us this very heavily cratered surface of our moon. All right. Well, next we want to head on to the outer solar system. And let me take a look at our poll. Again, we have a split here between, Jupiter and Neptune. So we will take a look at both of those. So we will head on out to Jupiter first. So as we're flying in, you can see all of these yellow lines here. Those are all moons around Jupiter. Jupiter has, at latest count, 79 moons, which makes sense since Jupiter is the largest planet in the solar system. It has a very strong gravity, and so even things like asteroids or comets that get just a bit too close to Jupiter, Jupiter's gravity is able to grab onto them and hold onto them, and they become moons because they start orbiting around Jupiter. And that's why it has 79 of them. Most of those are captured asteroids and comets. But there are a few others that we think actually formed around Jupiter in a kind of mini solar system fashion. And I'll show you some of our favorites in a second. But we'll take a look at beautiful Jupiter. We have these swirling clouds, these kind of stripes and bands of kind of orangish and whitish and brown clouds. We see swirls in them as each of the different color bands, the winds actually switch directions at the boundary between the different colored bands. And so you can see in those areas where you have those different direction winds, it creates a lot of swirling around there as you have the two directions kind of crashing into each other. And that's also often where we tend to find storms, the biggest of which is the Great Red Spot, probably the most famous feature on Jupiter. This is like a hurricane, but it's 2 to 3 Earths in size. So a very large hurricane, and has been going on for over 350 years. And it's actually something we're still trying to better understand of why this storm has lasted for so long. We don't really know. Although we have noticed it appears to be shrinking in the last decade or so. So that's another kind of mystery there, is why it suddenly appears to be shrinking a little bit. All right, well, let's go see. I think I'm going to take us to Europa, one of those moons of Jupiter that we think may have formed around Jupiter. And I'm going to this one because I brought up earlier how we are looking for life in other places. And Europa happens to be one of those places we're interested in looking. It may not look like it on the surface. On the surface, we just see a thick layer of ice. But underneath that ice, we think is a huge ocean of liquid water. I'm talking more water than we have total here on Earth. In fact, we think there might be twice the amount of water in Europa's ocean than what we have here on Earth. And from everything that we have learned from life that exists here on Earth, liquid water seems to be key. It's critical. Life needs liquid water. So when you have a huge ocean of it like this, that raises the question of, well, could life end up developing here? Because there's plenty of this resource that life needs. It has to be warm in order for it to be liquid, and that's another thing life needs, some sort of energy source. And we do know of life on Earth that lives underwater near volcanic vents. We expect the same thing down at kind of the bottom of Europa's ocean, and that's what's keeping it warm and keeping it liquid. So this is one of the places that we are going to investigate to search for life. NASA and other space agencies are actually working on a future mission to dive down into that ocean and explore it. And so we're still way far off from that happening. They're in the planning phases right now. But I am so excited, and I hope it happens in my lifetime because I want to see alien fish. I really do. So, all right. So the other planet that won is the furthest planet from the sun, which is Neptune. Now, what's interesting about Neptune, you'll see it's a very different color than Jupiter is. We have this pretty blue color. Now, on Earth, we know that blue is water, but that's not the case for Neptune. The blue here is actually caused by a gas called methane that is in its atmosphere, and that's what gives it that blue color. We do see some storms like we see on Jupiter, not quite as big as Jupiter's storms, since Neptune isn't as big as Jupiter, but still a very pretty, interesting planet. We don't know too much about, though, because we've only had one spacecraft travel by, and that was Voyager 2 back in the 1980s. And it's so far away from the Earth that it's hard for us to study with telescopes here on Earth. So we don't know as much about Neptune as we do, say, Jupiter because of that. All right, well, I think that's enough of our own solar system. If you want a more in-depth solar system tour, we have done plenty of those in the past. You can always check out our past videos in the videos tab of our Facebook page or on our YouTube channel, and I'm sure we'll do another one again pretty soon in the upcoming months. But this is a universe tour, so we want to start flying out and away from our own solar system because there is more to our universe than our home planet and our home solar system. So as we start flying away, it takes quite a bit before we start seeing those stars start to move around. The closest star to us, other than our sun, is Alpha Centauri, and that is a little over 4 light years away from us. So if you traveled at the speed of light, it would take you 4 years to get to the closest star to us. But as we travel at way faster than the speed of light, because our awesome virtual spaceship can do that, we enter the realm of the stars. And there are a lot of stars in our little neighborhood of our galaxy, and a whole lot more in the galaxy as a whole. And when we take a look at all of these stars, we start to see some trends, some patterns. It turns out that most of the time, stars don't form and live on their own. Most of the time, stars are in groups that we call clusters. And there's 2 different types of clusters that we see. There we go. The first kind, which is more common kind of within our galaxy, and typically has some younger stars in it, these are open clusters. And all of the open clusters in our galaxy are being highlighted by this kind of green, it's not quite a circle, but open clusters look kind of like this. This is probably one of the most famous open clusters. This is the Pleiades cluster, which you can see up in the constellation of Taurus during the winter. So the Pleiades cluster and other open clusters are typically described by having a few hundred to a few thousand stars within them. These stars tend to be a bit more widely dispersed. They're not like tightly packed close to each other. They also tend to have younger populations of stars. So these tend to be associated with areas that are actively forming stars and where we have these young new populations. Because they are so loosely grouped together, though, we don't see a lot of old open clusters because gravity from nearby stars tends to disrupt an open cluster after a few 100 million years and kind of pulls the stars out and away from that little grouping that they started out in. The other type of cluster that we see, other than an open cluster, is a globular cluster. Let me kind of turn us so we can see. You can see those yellow, see that's 5 sides, so that's a pentagon. These are showing us where these globular clusters are. And not a whole lot around us. Globular clusters tend to be on the outside, the outskirts of our galaxy in what we call the galactic halo. And globular clusters are called that because they literally look like a giant glob of stars. These tend to have much more stars than open clusters. We're talking tens of thousands to hundreds of thousands of stars. They're also much more tightly packed together. And so you get this really dense concentration, especially at the center. But then as you move out, the density kind of drops off. So it's not quite as packed in the outer areas as it is the very center. Um, you can also see that it tends to be a bit redder in color, and that's because it's an older population. So that blue color we saw in the Pleiades comes from really, really big, hot stars that are blue in color and very, very bright. So they dominate the light coming from that cluster. But those big, bright blue stars die very quickly because they just run through their fuel like that and die. And so with these globular clusters, because they're a lot older, those blue stars have lived and died long ago. And all that's left are smaller stars that tend to be redder in color and live for a lot longer time. And that's why we see that red color coming from them, because that's just the stars that are still alive after the amount of time that this cluster has been around. Because they are kind of in the outer edges of our galaxy, and because they're so old, we think that these are some of the first stars that formed as our galaxy was forming about, I believe it's about 10 billion years ago. I think our galaxy is about 10 billion. Eli, I don't know if you know or remember. Um,
Mm, well, how about this? No, I don't remember that, but we have a question that came in that I can ask you instead, and while I Google the answer to that.
okay.
Um, can Hubble or the new James Webb Telescope help us study the outer planets, or are they not designed for use within the solar system?
So our latest observations of Uranus and Neptune are from Hubble. So we absolutely can, but even with that, it's so far away that they don't look like much, and they're still incredibly difficult to study. James Webb is not quite made for this. It's made to look at infrared light instead of optical light, visible light that we see with our eyes. And that's because we want it to look at things that are really, really, really far away that we see best in that infrared light. So it's not quite designed for solar system observing. But great question. And I saw that came from my mom. Hi, Mom.
Um, as for the age of the Milky Way, 13.5.
13. Oh, so I was off.
Yeah.
Okay. Well, there you go. So these globular clusters, and they do date. The stars date back to about 13 billion years. So we think that those are some of the first populations of stars that formed as our galaxy was forming about 13 billion years ago. Thank you for checking that, Eli.
Yeah, of course.
All right. Well, other than stars, there's also a lot of gas and dust in our galaxy. And you can see that even in that just band that is our Milky Way galaxy, you see these dark streaks. And that's where we have gas clouds that are so dense and thick that they block the light from stars behind them from getting through. Now, these gas clouds we call nebula, and there are a few different types. One type is associated with the birth of stars, and these are called H2 regions or star forming regions. And you can see they're really concentrated there in that band of the Milky Way, because that is where these dense clouds are that lead to star formation. The most famous of these, or at least I think the most famous, is the Orion Nebula, which is in the constellation of Orion. It's in his sword. And this is a beautiful star forming region that you can easily see with a pair of binoculars or a small telescope. It is up in the winter, so it's not really up anymore right now, but that's a star forming region. Now, the other two type of nebulae are associated with the death of a star. So a star like our sun, when it dies, it's going to turn into a planetary nebula. And these are some of the planetary nebulae that we can find. You see, they're not quite as all concentrated just in that band of the Milky Way. They're kind of everywhere because stars like our sun are pretty common. And they look like this. This is the Ring Nebula because it looks like a ring. So it ends up happening as a small star, low mass star like our sun, when it dies. And in the like last stages of its life, the outer layers start to puff up, and the star grows into a red giant. As it puffs up, though, because the outer edges are now so much further away from the center of the star starts to lose its hold on those layers because gravity weakens with distance. So the gravity holding on at the surface isn't quite strong enough, and that material starts to just kind of blow away. And by the time the star has died, you end up with this kind of giant cloud of gas that's been blown away as the star died. And at the very center, you're left with what's called a white dwarf. And that's just the dead remnant of the star that's left over after this. And that forms that gas that's been blown away. While it's still very hot, it glows, and that's what we see here as a planetary nebula. Now, they don't last forever. That gas will cool off, and it will stop glowing. But while it looks kind of like this, and this is what's going to happen to our own sun. Now, the name planetary nebula is a bit of a misnomer. It has nothing to do with planets. It's due to the death of a small star. Now, bigger stars, much more massive than our sun, have a more violent death. When they die, they explode in a supernova. And what ends up being left behind is a supernova remnant. And here you can see where some of those are located. Not quite as many, because really, really big stars, that supernova, aren't as common as lower mass stars. And one of the more famous supernova remnants is the Crab Nebula. And it's very similar to what happened with the Planetary Nebula. It's just that explosion blasted out the gas, but while that gas is still hot, it glows and gives us this pretty glowing gas that was blasted out from our dying star. So what's really cool about the Crab Nebula in particular is astronomers on Earth actually observed the supernova that formed the Crab Nebula. So Chinese astronomers back in, and I'm trying to check my notes real quick, supernova 1054, there we go. Back in 1054, saw a sudden bright point appear in the sky, and it stuck around for a few weeks, and they kind of noted it on their star charts. And it's in the same area as we now see the Crab Nebula, and looking at how quickly the gas is moving outward, we can backtrack that to the date when the explosion happened, and it matches that observation. So Chinese astronomers back in 1054 saw the supernova that ended up creating the Crab Nebula, which is pretty cool. All right, well, let's keep zooming out here and take a look at our galaxy as a whole. So our galaxy contains a few 100 billion stars, give or take. They're all kind of in this disk shape, which is why our galaxy is known as a spiral disk galaxy. And sitting at the very center of our galaxy is a supermassive black hole. Now, this black hole, it is supermassive, so it is millions of suns worth in mass. But we're not in danger for it. The only danger that comes with black holes is when you get too close to it inside of their event horizon. And we are well enough away from that that's not going to cause us any problems. If you want to know more about black holes, we did do a show all about them a few months ago, I think. You can check that out. But as we look out, our galaxy is not alone. Nearby us, we are in what we call the local group of galaxies. And so each of these green points is a galaxy in our local group, and those blue points over there too. So our local group is 60 to 70 galaxies. Most of them are very small, what we call dwarf galaxies. But there are a couple of other larger galaxies as well. In fact, the Milky Way isn't the biggest galaxy in the local group. The biggest galaxy in the local group is the Andromeda Galaxy. Milky Way is the second biggest, and then the third biggest is the, oh my god, I can't believe I'm blanking.
Triangulum.
Triangulum, yes, thank you. It's been a long day of grading, guys. The Triangulum, yes, that's the third largest. And that one's quite a bit smaller than the Milky Way and the Andromeda. But as we keep flying out and we move out and away from our own local group, you'll start to see.
Before we get further out into infinity, can you show us where our solar system is?
I absolutely can. Oh, my mom is on top of it today. All right, so what I'm actually going to do is I'm going to turn on constellation lines. And so you can see right there where all those red lines are, those are connecting the stars that we see up in our night sky. And right at the center of those is where our solar system is. And this is always a cool thing to see, and I forgot to show it. So thank you, Mom, for this, by the way. Because you can see here that the stars that we see up in our night sky are a very, very small portion of all of the stars in our galaxy. We really only see the closest, like 4,000 stars to us. But that's where we're located. We're about halfway between the center and the edge of our galaxy, located in the, I believe it's the Orion Spur is the name of the arm that we are in. And don't ask me the other names of the spiral arms of our galaxy, because I don't know them.
One of them is Perseus.
Yes, one of them is Perseus, and I don't know.
And then is there a Sagittarius one?
It's possible.
I'll check.
I'm serious. I don't know. All right. So let's fly away. As we start flying away, we start seeing more and more colored dots appearing. Each of these colored dots is not a star. We're not seeing stars anymore. What we're seeing here are galaxies. Every single dot that you see here is another galaxy. And as we keep flying out, we see even more.
I looked it up. Okay, really quick. Perseus arm, Norna and outer arm, Scutum and Centaurus arm, Carina and Sagittarius arm, and the Orion and Cygnus arm.
All right, there you go, people.
There you go.
All right, but as we've flown out, again, all of these dots, these are all galaxies. Now, you may see that there are a couple of sections that look empty. Right now, they're kind of at the top center and the bottom center. These spaces aren't actually empty. What's happened is these are areas where, in order for us to observe them, we have to look through our own galaxy. And all of the gas and dust that we saw in our galaxy blocks our view of what lies behind it. So we just can't see what's in those areas. But we fully suspect that they look exactly the same as the areas that we can observe. So as we keep flying out, we find more and more and more galaxies. In total, we believe there are at least 1 trillion galaxies in our universe that we can see right now. Each of those with billions of their own stars. So there are quite a lot of stars out there. I think my favorite saying that I've heard is there are more stars in the universe than there are grains of sand on all the beaches on Earth.
Yeah.
Which is just mind-boggling how much is out there. And we're
Speaking
just,
of,
yeah,
oh, sorry.
nope,
Speaking
go
of
ahead.
mind-boggling, we just got a question. The distances in space are mind-blowing. How much or what percentage of space is empty? No gas, no stars, no planets. I thought this was pretty cool. Can I maybe take this one to answer?
Absolutely.
So the really interesting thing is that not only are the spaces like in between galaxies and planets and stuff like that empty, of which 99.99999% would be empty, but also the space like you are 99.999% empty because you're made of these atoms, and the majority of an atom is empty space. The adage that they always say is if you take like a professional football stadium and put a football at the middle of the field, the football at the middle of the field is the nucleus of the atom with the like protons and neutrons, and then the rest of the stadium is empty space. So not only are the distances between different things empty space, but you are empty space, the desk that I'm sitting at is empty space. It's all empty.
Yep. It's crazy.
Yeah.
But as we have gotten really far away from home, we reach the edge of our observable universe. Now, I phrase that very specifically, observable universe. And that's because this is what all we can see right now. Light takes time to travel, and our universe is only about 14 billion years old. So we can only see the things that have had time for the light to travel to us. There could very well be a lot more out there that the light just hasn't had time to get to us yet. So this is what we can see right now. As time continues to march on and light from more and more distant objects finally has time to reach us, our observable universe will probably continue to grow. I say probably because the expansion of the universe may play a part here, but I don't want to get too much into that because that's getting really mind bending, crazy stuff. But yeah, we have reached the edge of what we know. And now that we've reached the edge, let's fly back in through all of these galaxies, back to eventually our local group of galaxies, to our home galaxy, the Milky Way, into the Milky Way through the stars, finally getting to our home star, and back home to our solar system. And so there we have it. A little bit longer than 30 minutes, but a roughly 30-minute tour of our universe, or at least what we can see in about 30 minutes time. There is a lot more out there. Their universe is huge, as we have seen, but we hope that you've enjoyed seeing some of the highlights and some of the cool stuff that is out there. Eli, do we have any more questions?
Nope.
No?
More.
All right. Well, if you do have any more questions, now is a great time to leave them down in the comments for us. And I'm going to trust you, Eli, because my phone is apparently not showing me comments right now,
Yeah, of course.
which does happen sometimes. All right. So while we wait and see if any other questions roll in, let me tell you what's coming up over the next week. We've got leading up to very, very exciting stuff next weekend. So on Saturday, Eli is going to give us a little bit of an update on what's happened in space travel over the past year. Because since about a year ago, we have started launching astronauts from the United States again. And so Eli is going to give us kind of what it takes to get people into space and what's happened over the past year. And I hope I didn't see a shocked face on you, because you do remember you're doing this show.
Oh no, no, yeah.
Okay.
Sorry, I didn't mean to look at
Next Wednesday, We're going to do a fun show that ties into the activities that we're going to be handing out at our astronomy day. And so we're going to take a look at some of the techniques that astronomers use to study the universe and show you what's going to be in the kit that we're giving out in astronomy day that can help you do that yourself at home. And then next Saturday is astronomy day. And so we will be outside the planetarium from 2 to 4 p.m. passing out these activity kits. They come with 3 activities. These kits are limited in number. We have a set number of them that we have been able to put together. So it is first come, first serve. So definitely stop by and claim your own activity goodie bag. We'll also have fun activities and demos for you to see, some solar viewing if the sun's out. We're gonna raffle away Saturn Lego 5 or Lego Saturn 5. It's gonna be a great time. We're so excited. And then that evening, oops, we will be doing a live stream for our typical Saturday time slot. We're going to do a little bit longer live stream because we're going to have on some guests. Bob King is going to join us, Astro Bob, as you might know him. We're going to have Jim Rock is going to be there. Eli and Lindsay are going to tell us a little bit about some of the stuff they've been up to over the past year. Because if you didn't know, they're actually currently doing research in astronomy on intermediate mass black holes, which is really cool. So they're going to give you a little bit of a taste of what kind of student research is like. And yeah, we're excited. We're excited to get back out. And yeah, I think I'm
We're
gonna
gonna
stop.
keep my door for a second, but intermediate mass black holes, astronomy day.
We are very excited. So yeah, make sure you stop by. All right, Eli, any other questions come through?
Nope.
All right, well, we will end it there then. Thank you so much, everyone, for joining us. Don't forget, we do this every Wednesday and Saturday at 7 p.m. Central. We have typically tried to do different shows every week. And yeah, we hope to see you again. Have a wonderful rest of your day, and we will see you next time. Bye, everyone.
Oh,